All right. So we're looking at a new section here. We're looking at 2A.2.3, and it's talking about binomials. Okay, binomial, just like a bicycle, two wheels. A binomial has two terms. So look here, that's a binomial, 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 binomial. And the reason why it's all configured here is because the binomial theorem says, based on the exponent of a binomial, you have all these identities, and the identities are based on Pascal's triangle. Okay? So if we're looking at Pascal's triangle, I already started mine here, but it's really just adding what's above it, remembering that on the outside there's always these invisible zeros. So, when I had 1, it was 0 and 0. So 1 plus 0 is 1, 0 plus 1 is 1. And then I look down here further, 1 plus 1 is 2, 1 plus 0 is 1, 1 plus 0 is 1. Keep going. 2 and 1 is 3, 1 and 2 is 3. 0 and 1 is 1, 0 and 1 is 1. So you can keep building this. You keep building this, you're going to end up with ones on the outsides. That's going to be the pattern. We keep building. And actually, that's as far as we went, only to the 5th row here. But I can keep going, right? I can keep going. It's just addition. So 20, 15, 15, 6, 6, 1's on the outside. Okay, so you can keep going and have all these rows adding up, just adding to be the value below it is the 2 above it added. Right? It starts to create a pattern, and it's a pattern that is, it's just, hey, add what comes before it. So it's building, it's getting larger numbers, and we know that actually when we are using it in the binomial expansion, we want to look at it this way, as it's noted here. This is row 0, row 1, this is 2, 3, right? 4, 5, 6, and so on. And as a video that we watched, the TEDx video on Pascal's triangle, we know some things about this. Check this out. 11 to the 0 power, 1. Oh my God, watch this. 11 to the 1st power, 11. 11 to the 2nd power, 121. Oh my God. 11 to the 3rd power, 1,331. Okay? Either hate it or you love it. It's something that is a pattern, that is a recognizable pattern, but within it, what it does is create all these little secret things. So for one, it tells us, there's so many things it shows us, but I just thought that was interesting how the rows are really just the 11 raised to that power. Okay, and that's just the raw numbers. We're going to go a little deeper than that slightly. All right. But just know this is where this comes from. That's how it's kind of created. We just add the numbers above it. This is just extra, but we're adding the number above it. The two numbers give you the number in between below. Okay. So here's how it's going to be helpful, guys. Because if I have a plus b to the 1st power, it's just a plus b, because anything with the 1st power is the same thing. Okay. If I have a plus b to the 2nd power, then if we identify what a and b are, we can use the template here and just put the a's where the a is, put the b value where the b value is, and it always has this 1a squared plus 2ab plus 1a or 1b. Look, 1 plus 2 plus 1. So these Pascal triangles, these really are our coefficients. Okay? They're going to be the coefficients of the new expanded binomial. Let's see if we can see the same thing here. This is a 1, this is a 1. A plus b to the 3rd power is 1a plus 3a squared b plus 3ab squared plus 1b. So it expands in that way every single time, where if you had, a plus b to the 100th power, you'd have to do 100 rows of this Pascal's triangle. It'd be a huge undertaking, but you could find it from Pascal's triangle. Okay, So you're going to have Pascal's triangle. You're going to have this available for the test, for the quiz, coming on. I'll talk about it next week. It's probably going to be before Thanksgiving. But for that, I'm only going to give you to row 5. I'm not going to go any further than that. Okay. Now, let's see how this is going to work. First things first, step 1. Find your A and your B. By the end, when we simplify, you're going to see how this goes. By the second example, you'll definitely see a little more. So I don't expect you to get it right off the bat. Okay? It's a pattern. It's a pattern. So if you're not good at math, but you're good at like Tetris, you might be able to see this and understand this a little better. And if you really don't like Tetris, then you'll use these notes and you'll make it through anyway. Okay? So look, A is X, B is 2. Everyone okay with me? Okay with me doing that? Right? It's a binomial, so you just look inside the binomial. Your A is the first term, your B is the second term. Don't forget that it's positive 2. It's positive 2. Okay. That's why I put a 2 here. All right, so now we have our A and our B, and then we need to look and see what our exponent is. Our exponent is 3, so that tells me to look at row 3. Based on the exponent, we're going to look in the row 3. Okay. Now watch. I'm going to go to row 3 here, and I look and see, okay, here's going to be my coefficients. So here's what I want you to do first. Actually, yes, I do want you to do this. No, I don't want you to do that way. You know what? Because it's that kind of year, and we won't have too much time to go in depth to use this creatively. I'm going to let you use them like identities. Just like how we had the difference of 2 squares, the sum of 2 cubes, all those. This is going to be available to you. So I want you to carefully look at row 3. We're going to go in here, and we're going to leave a parenthesis for the A. This is going to be A to the third plus 3A squared times B plus 3A B squared plus B, whoops, damn, magic, plus B to the third. Okay, you could write it much better than that, please. But why didn't I write that right here? I'm going to do that. Sorry. So we're going to put A here plus 3A squared. We got a B here plus 3A B squared plus 3. There's a clever way to learn how to use this so that you can be really creative, but we just won't have time to do more than one lesson on it. So I'm going to teach you the practical. All right. So I just rewrote this. That was messy. I didn't want that as my main thing. But once you have your template, which came from row 3, look, 1A to the third plus 3A squared B plus 3AB squared plus B to the third. Okay. So now all we have to do is go in. Let's see. Find the reference row based on the exponent. We did that. We wrote out the coefficients, input A and B. Actually, here's the deal. Take this out. Step 4 is out. That's more on the creative approach, but we're not going to learn that depth today. So now, with that, now we just write out the coefficients and input A and B. Let's do that. X is A. B is 2. We had already figured that out in the beginning. Okay. Now we just have to go in and simplify it. Let's do it. X to the third doesn't simplify. That is the final. 3 times x squared times 2. We can multiply the 3 and the 2. We get 6. X squared stays the same. Plus 3 times x times 2 squared. 2 squared, if we're thinking PEMDAS for this one term here, 2 squared is 4 times 3 is 12. 12x. Finally, 2 to the third power. 2 times 2 times 2 is 8. Literally, it's magic. I love it. So what we just figured out is that x plus 2 to the third is equal to all that. And you're like, well, how did somebody do it before Pascal's triangle? This is what they would do. They would go, oh, it's x plus 2 to the third power. So I'm going to go x plus 2, x plus 2, x plus 2. This is like double FOIL. This is like, this is so much work. Because first you have to FOIL that, and then you have to FOIL each of those. Okay. But this, instead of doing this, we're going to use Pascal's triangle. Just put the template out there, put in our A and our B, and simplify, and we're done. Okay. All right. Let's see. I know everyone's thumb is sideways right now. It's fine. Sideways? Yeah. Let's look at example 2 down here. Tell me in the chat so I can see if you guys are all out there. What is A equal to and what is B equal to? Go ahead and throw it in the chat. I need a couple answers. What's A? A is equal to, and then B is equal to. Nice, Devon. Perfect. Well, actually, look a little closer, guys. Don't forget about this. Oh, you want to change your answers? There it is. Thanks for changing it. All right. So we just have to look close. We have to look close. Whoa. Closer than I thought. We only need to look at A. B is going to include that negative. Up here, probably would have been better if I also put the second part is the sign is included in it. So A is 3x, B is negative 2. Okay. Let's zoom out again. All right, so we found A and B. That seems pretty easy. We just have to be careful about good zoom out. Perfect. And we need to now look and see, well, what is the exponent? It's 4. So that means I'm going to use row 4. Row 4. All right. So I look at that, and I know that this is then equal to, let's go ahead and look at row 4. That's going to be this one. So we're going to be looking at this right here. Okay. But every place that you see an A, we want to just put parentheses around there and kind of keep it ready to input our A value. So watch. This is A to the 4th plus 4A to the 3rd times B. You just got to go slow. 6A squared B squared plus 4A B to the 3rd plus B to the 4th. There is a cool way to remember that, but I think we'll be okay with just using this for its utility. Okay. All right, go ahead and put your value that you had for A, our 3x, go ahead and put it anywhere you see that A that we left open for it. Okay. So we're using this as like a template. And then go in and put in the B, which is negative 2. Put that B in there somewhere. Anywhere that we said we needed to be. All right. Now to simplify this, I'm going to use, that was our last step, is to simplify it. And we're going to figure out what 3x minus 2 to the 4th is equal to. That's our next step. I'm going to do the expand method. Just so we can remember what it is. Because look, 3x to the 4th is 3 times x times 3 times x times 3 times x 3 times x. Okay. So if you expand it, you could see that this term is going to end up with 4x to the 4th. But look what we have. 3 times 3 is 9, times 3 is 27, times 3 is 81. So this ends up being 81x to the fourth. Use your calculator if you need on that. No worries. All right, the next one I have positive 4 times, it's going to be 3x to the third. So we're going to have 3x, a 3x, a 3x, all of them multiplied together, times a negative 2. All right. So I like to multiply all the numbers together, then all my variables. 4 times 3 is 12, times 3 is 36. Now is where I just need to get a calculator and stop trying to show off. 4 times 3 times 3 times 3 times negative 2. Whoops, that didn't work. Let's see, 12. 12 times 9. All right, so we get negative 216. How many x's do we have? 1, 2, 3. X to the third. You got to work through them. You got to trust the method here. All right, so here next we have 6 times 3 times x, 3 times x because it was squared. And then we have a negative 2 and a negative 2. So we got to multiply all these together. And keep in mind that the negative times a negative will be a positive. So I'm going to go ahead and keep that in mind and just input those as I get to it. 6 times 3 times 3 times negative 2 times negative 2 is positive 4. So I'm just going to do times positive 4. Oh, God, look at this. Plus 216 x squared. Here I'm going to expand it. 4 times 3 times x times negative 2, negative 2, negative 2. So I'm going to just simplify this here first, just so I can think about it a little clearly here. Negative 2 raised to the third. Why am I having trouble with this calculator? Oh, that's why. 2 negative raised to the third. Yeah. So this is just negative 8. Okay. Negative 2 times negative 2 is positive 4 times negative 2 is negative 8. So let's multiply negative 8 times 4 times 3, because those are the other numbers that I can multiply. Everything's multiplied together, and we get negative 96. How many x's do we have? 1 x. Finally, we have negative 2 times negative 2 times negative 2 times negative 2. There's 4 of them. Okay, so here we got negative 2 times negative 2 is 4. Here, negative 2 times negative 2 is 4. So all together, we multiply everything together and get positive 16. And we just figured out that this 3x minus 2 to the fourth power equals that. We're lucky, because look, this is what we'd have to do. 3x minus 2 times 3x minus 2 times 3x minus 2 times 3x minus 2. That is horrible. To have to do that one at a time over and over and over and over. You would have so many terms if you did this. Okay, so it's kind of like magic. We look to the exponent. We find a and b first. We find a and b. We look to the exponent that says look on the fourth row. So we go to the fourth row and we input very carefully our parentheses with what's going to go in there. We input what goes in there, expand it, contract it to find and simplify our final answer. All right. Thumbs up, sideways, down. How do you feel about it? What do you think? What do you think? Yeah? Was it like useful and a little less complicated than you thought it was going to be? Was it a little bit less complicated, or it's complicated? It's complicated, huh? I've just seen it before. Yeah, it is complicated. But it is useful. We don't have to do all this. We can use Pascal's triangle. We can use this up here to figure out what each of these binomials will expand to. Okay. That's really all I had for you guys. Let me see. Let me go and stop the video. Thanks for watching. If you're at home watching. Stop.